Welcome to the video tutorials for SILCS Bio. In this video, we will go over how to run SILCS simulations using the graphical user interface. For this tutorial, you will need a prepared protein structure in a PDB file format. Before proceeding, please ensure that your structure has all hydrogens added, any missing residues built or at least capped breaks, added appropriate termini, and added appropriate protonation states for the titratable residues. Note that we typically remove all ligands and solvents from the protein structure. Metal ions can be retained. Here we will use the KRAS protein with G12D mutation structure with PDB ID 7RPZ. The information discussed in this video is also available on our documentation website docs.silcsbio.com. Go to Quick Start, then go to Graphical User Interface Quick Start, then go to SILCS Small Molecule Suite Quick Start, and then you can go to SILCS Simulations using the GUI. Okay, let's start a new SILCS project. Hope you have configured your remote server at this point. If not, you will have to do before moving forward. Now we'll go to the SILCS simulation section on the home screen. If you hover over the title, you will now get a sharp description that pops up. Here we are going to click on the new SILCS project button. Next, we must choose the type of target molecule. It can be a globular or membrane protein or an RNA. In this case, we have a globular protein, so we click that. Next, we come to the setup page. Here we need to provide some inputs or choose some settings. First, we need to give a project name. Second, we have our default remote server auto selected. We can change it if we want from the drop down menu. Next, we select the prepared protein PDB file. Then we must choose a simulation mode, standard or both standard plus halogen or halogen for a project different than this project. Here we are running standard only. There are some advanced settings. Most of them can be we can leave unchanged with default settings. For this system, we are going to change the simulation temperature to 300K, 310K, while default is 298K. Then we are going to click setup button. This will bring up a command execution window. Our input files will get transferred over to the remote server and SILCS systems are going to get built. We can see some output that one would see if they used the command line directly. Now this may take a few seconds. The setup is complete and we can click the green button. Next page shows the location of the project on the remote server if needed. Next, we can submit the simulation jobs and track the status. Now, we went back to home page to show you how you can continue a project. We click on the Continue SILCS project under the SILCS simulation section on the home page. Here we will have a list of all our SILCS projects with some information about each project. This project status is setup completed, so we click here. This takes us to where we left the project. We can now click on the button Run Standard SILCS Simulation. This brings up the command execution window and we can see our jobs got submitted. Let's click the green button. Now as the page gets reloaded, we can see the simulations are running and the status information is provided. We can click the refresh button to update the status. And let's come back after some time to check again. Now it's been a little more than 14 hours since we submitted jobs. Let's go to continue SILCS project and select our project. The status shows that we are in simulation phase. As we click, the job status is being fetched and loaded. We can see that depending on the type and speed of the GPU on respective nodes the jobs were submitted to, they have progressed towards the finish line. If all the jobs are finished, we can move on to generating FragMaps. Again, let's go to our SILCS project from the continue option, and as we can see that all 10 jobs are finished. Now we are going to click on prepare FragMap button, and then we are going to click on the generate FragMap button. This will start collecting and analyzing the trajectories to generate maps for each of the 10 systems serially and can take up to 1 minute per system. As you can see, we fast forwarded here and it took about 9 minutes total. After that, convergence check is done by generating the frag maps from first half and last half number of systems separately and then calculating the overlap coefficient between them. Finally, the frag maps are calculated based on the analysis of all 10 systems and collected in the directory that starts with silks underscore fragmaps underscore protein pdb prefix. As we can see, we are not fast forwarding this part and can take up to couple of minutes based on the size of the system. Do not close the program or window during this process. Once complete, a green button will appear with your silks fragmaps directory generated on the remote server. Click on the green button and the 6 FragMap directory will be downloaded to your local machine and will be accessible through the show project directory option. Notifications for the downloading process will appear on the right upper side and go automatically in few seconds. Downloading has finished and the frag maps are loaded to the stage for visualization. We can adjust our view of protein and frag maps as we explore. We can go back to the home screen uh, and always come back for visualization from the continue SILCS project option.
Alright, thanks for watching the tutorial. See you next time.